All right, hello everyone, welcome. Hope you all had a great weekend. Yeah, we're obviously here this week to talk about the exam. So the exam is the big thing that's coming up later on this week. I'm going to spend a few minutes up front just kind of talking about some general logistics for the exam, maybe try and clear up some common questions that I get about the exam, and then I'm hoping we'll have a big chunk of time at the end to do some practice problems for the exam. I'm really hoping that you'll help me out with that by, asking me some questions or asking me to work through certain problems. But the goal today is to get you as prepared as possible for the exam that's coming up on Thursday. So let's talk about logistics first. I know for a lot of you, this is your first time taking an exam in this class, first time taking a comp sci exam. It's in the evening, so it's Thursday evening, this Thursday, from 6:30 to 8:30 p.m. It will be in various locations. So I actually just received the rooms that we'll be able to use right before class. So I have not been able to post the rooms yet. However, that's going to be on my to-do list for tonight. It will be based on your ID number. So the last 3 digits of your ID number are going to tell you which room you're going to go to. I will make a post on Piazza once I get this all figured out. Again, it'll probably be tonight. I just got that information today. I would advise you, once I do post this information, to make sure you know where you're going. Sometimes these are in rooms that students don't often use for class or for other purposes. So if you are not familiar with the room that you're being asked to go to, it is definitely in your interest to make sure you find it before the exam time, because the exam will be starting right at 6:30 and take 2 hours, which, especially for this first exam, is probably plenty of time. But yeah, if you have accommodations, I hope that you've already set up a time to take the exam with disability resources. We will not be able to accommodate additional time requests on the exam. This exam is running from 6:30 to 8:30 if you're taking it with us, okay? You are allowed to, so let me actually start off with what you're not allowed to bring, which is no electronic devices of any kind. Actually, the only thing you really are allowed to bring is a sheet of paper. So you can bring one sheet of paper, regular size sheet of paper, right? Notebook paper, printer paper. I'm not going to sit there and measure it with a ruler or anything like that. It's a regular size sheet of paper. If you come in, you bring a sheet of paper that's as big as this desk, all right, we're going to have a conversation about that. But if you bring in just a regular size sheet of paper, that's totally fine. You can put whatever information you'd like on that sheet of paper. So front and back, handwritten or typed. I don't care how you get the information on that sheet of paper or what information you put on that sheet of paper. The only thing that I request is that if I'm walking through the exam rooms, and I may do this, and I say, hey, let me see your sheet, I should be able to look at it and read it, right? Understand what's on your sheet of paper. So in other words, what that means is if I need to put on 3D glasses or one of them funky Apple things to read your sheet of paper, that's not going to work, right? Which there's no electronic devices during the exam anyhow. The thing I get asked most often is that students will need a calculator on this exam. While there may be some problems that ask you to do some arithmetic, there's certainly nothing that could not be completed very quickly on the side if you need to. But even then, the arithmetic on the exam is meant to be simple enough to honestly do in your head, preferably. It's not going to be any kind of math that would require a calculator to use. So you do not need a calculator for this exam. You will not be allowed to use any kind of calculator, any kind of material on this exam, except for that one sheet of paper, which you can put, again, whatever you want to on there. A lot of times people ask me how to prep for this exam. What should they put on the sheet of paper? What should they prioritize for this exam? That's a very personal question, right? I think actually putting together your sheet of paper is kind of a study tool for the exam because it helps you identify the weak areas. What areas do I need to focus on? Probably arrays, right? But maybe there's other things that you're not too sure about still. That's the stuff that goes on your sheet of paper, and that's a good way to study. Identify the areas you're strong at, the areas you're weak at. The other suggestion for studying for exams is kind of like what I am about to do with you today, which is just practice. Just write as much code as you possibly can. Make sure that you get as much practicing that skill, because honestly, I want to see what you've practiced, what you've learned so far. And so that's what the purpose of the exam is. The last thing that I am going to mention, I get a lot of questions about what's going to be on this thing. So obviously the topics that are going to be on this exam, pretty straightforward. Anything we've covered up until this point is fair game. So modules 1, 2, and 3 are going to be on this exam. In terms of what kinds of questions, what kinds of content will be on the exam, I've given you this information already. So if I go to the page, I know for a fact that some of you are already aware of these resources, but just in case you aren't, there are some materials here to help you prep for the exam. This is a quiz labeled past exam questions. These are quite literally questions that have been ripped from past exams, and every semester I go and I add the previous semester's questions. So these are quite literally questions that have been on exams in the past. They're multiple choice, they're fill in the blank, they're true false kinds of questions for the most part. So if you're looking for examples of what kinds of stuff you might see on the exam, here it is. And then the other resource that I posted for you is called Exam 1 Coding Prep. This is a repository. This is actually like an assignment repository like you would get. And within that repository, you'll see that there is a lot of coding practice. This stuff up here at the top, labeled non-exam, these are not examples of stuff that's been on the exam, but they're just extra practice. There's extra practice problems. Everything that's in this past exams section, these are actual questions that, again, have been on past exams that I update every semester with the exam information. So all of these code reading questions have been on past exams. All of these code writing questions have been on past exams. Will you have multiple choice questions, true false questions, fill in the blank questions, code reading questions, code writing questions on your exam? Yes, absolutely. All of the above, yes. Do I know how many multiple choice questions are going to be on the exam? No, I do not. I also don't think that information, people ask me that question a lot, and my question back to you is, if I tell you there's 17 multiple choice questions, does that change how you study for the exam? I don't really think that it does. The exam is not testing you over your ability to answer multiple choice questions, it's testing you over your knowledge of the material that's been covered in this class. So I would encourage you to please not focus on the format. I understand that there's anxiety around not knowing what's coming at you. That's just kind of part of what an exam is, right? I'm not going to tell you how many multiple choice questions are on. I don't even know. I haven't even written a thing yet, so I cannot answer that question even if I wanted to. I also don't think it matters. Practice. Practice writing code. That's the best thing you can do. Any time spent wondering about what I'm going to put on the exam, I think is time that you could spend writing code and getting better at writing code and reading code and working with code, which is really the point of the exam. So that's my little exam rant. Does anybody have any questions about logistics? Times, places. I know I haven't posted the places, but I will. Any questions about that kind of stuff before we hop into coding? Any questions at all that I can address? Yes?
Can you use both sides of the paper?
Yes, absolutely. Yep. Both sides of the paper, fine, yeah.
This exam only covers module 4.
We haven't done module 4 yet. Yeah, module 3, yep. That's as far as we've gone. Module 4 will be on the next one. Any other questions? I guess one other thing I should note about logistics-wise, that's kind of related to the exam, there's no studio this week. So, do you have to come to class on Wednesday or Thursday? We're not going to mark whether you're there or not. So, use that information to whatever you'd like to do. However, we'll still be there. The TAs will be there. I'll be around, although I'll probably be in the copy room making, a bajillion copies of the exam. And prepping for the exam that's coming up. But the TAs will be there. I'll be around as well. If you have questions about the exam, come to class on Wednesday and Thursday. Ask the questions. That's a great chance to get some one-on-one attention from a TA, which you're not going to be able to get today, obviously, because it's just me up here. If you want to turn in homework assignments, come to class on Wednesday or Thursday. You can turn in homework assignments. You can do all that stuff. We're going to be there. Is there a studio? No. Are we going to take attendance and ask if you're there? No. But we will still be there, still a resource for you. So come on in if you need help. Okay. At this point in time, I would like to spend the remaining hour and 10 just doing as much coding practice, hopefully, as possible. I'm happy to go over any questions that you all would like, although typically students do ask me to go through these code reading and code writing questions from past exams. If there's any of those in particular that maybe you've taken a crack at and you want to see me work through, I'd be happy to do that. I'm also happy to talk about past assignments, except for obviously assignment 3, which is not quite due yet, and studios and things like that. So, anything is fair game. But if anybody has a suggestion of a problem they would like to see me do, I would love to hear it. Otherwise, I'm probably just going to pick one at random and start going through it. So does anybody have any questions? Yeah?
Probably Studio 3.
Studio 3? Okay. Have you watched the studio review video yet? Because, I'd rather point you in that direction. If there's a specific thing you want to talk about, I'd be happy to answer. But if it's just go through Studio 3, then I think... now, if... okay, not too specific, yeah. If you just are looking for a general review of the studio material, which I think is very valuable, that's a great. Thank you for reminding me. I do post these Studio 3 review every week. I recorded this one last week, posted every Friday. So please check that out. If you have specific questions, maybe you did it a different way, I'd be happy to chat with you about that. Any other questions, any other coding problems that you all would like for me to yell over this drilling that's happening right now? Otherwise, I'm just going to start picking some. And I'm probably going to pick some that deal with arrays, because I feel like that's probably what a lot of people have questions about, are arrays. Although we don't have to do all arrays. Yeah, in the back.
So we do more examples of like for-each loops, because that's really fast.
For-each loops? Yeah, I can try to work in some for-each loops. Absolutely. Absolutely. I'm trying to think if there's any off the top of my head that require it. I know there's a code reading problem that has a for-each loop in it. Here it is right here. I remember it because I just added it to the repository. This one was just on the exam last semester, so I just added this lately. Let's talk about, this is a code reading problem. So if you haven't taken a look at the repository yet, there's kind of two flavors. Code reading is, we expect you to get out a sheet of paper, right, and write down what you think is going to be printed by this code before you run it. So let's talk about it for a second. See if we can figure out what this code is going to do. You can, of course, always run it and see, but you won't be able to do that on the exam. So definitely try to practice this yourself on a sheet of paper first. I'm just going to come down here and maybe put down some comments, see if we can figure out what's going to happen. I've got two arrays. One with integers, and you can see the values that it contains. We're using the curly bracket syntax to create this array. I've got another array here with strings, and you can see the letters that it contains. All right? And this guy right here is a for-each loop. How do you know that's a for-each loop? What's a sign? What's a giveaway? The colon. The colon is the sign. There's also only two parts, whereas the other style of for loop that we saw has 3 parts, right? 3 defined sections. So for-each loops just have the 2 parts. And so, again, the way to interpret this, for every integer value v in next. That's how I would say that in English. For each integer value v in next. So that means the first time through this loop, v is going to have the value 2. The next time we go through this loop, v is going to have the value of 3. The next time we go through the loop, v is going to have the value of 5. And it's just going to keep doing that until it runs out of values. That's why it's called a for-each loop, right? For every value in this container. So if we try to apply that to the statement that we see here, we can see that v is being used as a, what's that word? Index. V is being used as an index to the array that is called out. We know that v is being used as an index because I see it being used inside of brackets. So the first time through the loop, v is 2, which means that out bracket v is going to be a. 1, 2. Wait a second. Why not m? Really? Yeah. We start with 0. We start with 0. It's not 1. That's actually position 0. This is in position 1. This is in position 2. So when I take the value of V and I plug it in as an index to this array, I get A back out. All right. What's the value of V the next time through the loop? 3. Just the next value from the array. So out of V, that's what's getting printed. Well, if this was 2, then this guy should be 3, right? And by this point, I feel like most people kind of get the hang of what's happening here. It's not really a, it's kind of a repetitive process. So I'm going to plug the 5 in and get T, right? Then we plug in a 3 again. Well, we already have that one. We already did 3. Plug in 1. That's going to get us this M. Let's see if I can just... 1 gets us the M, and then 0, as we've already discussed, is the very first value in any array. So that gets us N. This is the answer, autumn. It's going to literally print out the word autumn. In fact, I can prove it to you by running this code. You can see there it is, the word autumn. Pops right back out. Yeah, what's up?
If this was a test question, your answer on the test, you just want it written vertically because it's a line out?
Correct. That does, and that's a good question. This matters, right? We've seen both versions of this, and it makes a difference. If this question was given to you like this, then what would the effect be? With the print instead of println. How's that change it? It's all going to be on one line. Yeah, it's all going to be on one line. That matters. That matters. Yes?
So for each loops, the way they go through that next array, it just goes left to right?
Correct. In order. Yep. And if I change the numbers here, it'll use those the next time I run it instead, right? So, if I change this to be another 3 instead of a 5, then that's going to have the effect of changing this letter, right? This is no longer a T, but now it's going to be another U, right? 3 U's instead of the 2 that are needed. Yep. Great questions. Any other questions about this example? Or anything we've covered so far? It's a good one. It has arrays and for each loops. Covered both. Yeah, when I ask you, code writing questions, I'm generally asking you to be as exact as possible. I'm asking you to quite literally play the part of the computer. So if you're thinking about how to tackle these, pretend you're the debugger. Walk through it line by line. In fact, that could be potentially even a good way to study these problems, especially if you can't figure it out. If you look at one of these and you're like, I have no idea what this code is going to print out, I know that you can run it and see the answer, which is maybe helpful. But I think even more helpful would be to use the debugger. And so as a general refresher, I almost always try to use the debugger at least once in every class that we have. Set a breakpoint on the exciting part, which for me is probably this loop, right? That's probably the exciting part. Start it up in debug mode and watch the values. As you step through this, you can see that there V has the value of 2, which is the first value from the array. And then it's going to print out the value of out at V, which is going to be the A. So next time I step, there's my 8. All right, we finished that value. The next value for V is going to be 3, just like we would expect, right, from the array. I can see it here. So that gives us the first U. And then it's 3 again, next U, right? You can step through this code until finally we get down to the very last value of 0. At this point, the for each loop is going to understand that there are no values left. And so it quits. We're done. The program is over. That is, absolutely, without a doubt, the way I would recommend studying these problems if you're unable to just figure them out yourself on paper and pencil. Notice that when I actually worked through this, though, I was pretending to be the debugger. I was writing down the value of v at every step as it changed, and seeing how that changed the print statement. That's how you do these problems. Yeah. Pretend you're the computer. Pretend you're the debugger. Walk through the code step by step. All right, I think I've talked about that problem long enough. Does anybody have another one they want me to see or another suggestion? Yeah, what's up?
I have a question about like the for each.
Okay, sure.
How did you define it, like setting in terms of English?
Yeah, so when I come across a line like this, because the colon is here, I know it's a for each loop instead of a for loop. So I would actually say it that way. For each integer value called v in the array called next. That's how I'm going to read every single one. These could be different, right? I get to choose this, so I can call this whatever I want. I can call this, value, or name it after myself. That's a terrible variable name, but I can do it, right? It's my choice what to call that variable. This, however, is just whatever my array is called, right? Whatever array I'm interested in. And it works for any array. So if I wanted to have a for each loop that just went over, the string array directly, I can do that, right? I can say, all right, for each loop over the out array, but then notice I had to change the type to match, right? And now every time I go through this, I don't have to plug it into, I can't use v as an index anymore, but I can just print it out directly. And while this isn't the problem as it was originally given, you can see that, okay, I've now just run my for each loop. It prints out every letter from this string array, one after the other. Always in order. Yep. Great questions. Any other questions? Yeah.
For the variable v created like inside brackets,
Mhm.
we try to refer to the variable outside this for each loop, it will show in there, right?
Correct. It'll be an error out here. Yep. We haven't, I don't know if we've discussed that topic yet, or I don't think we have. I think we will, though. That's something that's called scope. We absolutely will discuss that. I'm not sure that's a big concern for this particular exam, though. Yes?
For arrays, I remember, I don't have a specific example problem, but
Okay.
I remember during lecture you talked about parallel arrays.
Uh-huh.
I was just wondering if you could like define those again, and also what their use is.
Sure. So we actually haven't given you an example. Well, I'm trying to think. I don't believe we have given you an example of using parallel arrays yet. But on assignment 4, you'll have an actual example that uses parallel arrays. I think, I don't know that I even have. I mean, maybe there is one in here somewhere, but I don't know off the top of my head if I have one in here or not. But I can, of course, generally describe the concept. I would say this is not an example of parallel arrays. You might be confused into thinking that it is, but it is not. Parallel arrays implies that the values in these two, the values in the same position in two different arrays are related somehow. So the example that we saw from class had one array of people's names and then another array of people's scores, where the name in position 0 corresponded with the score in position 0, right? The same index refers to the same unit. That's not the case here. There's no direct relationship between these values, right? N has no relationship to this 2 at all. So parallel arrays are used when I have information in two different types, or just two different collections, I guess, of information that are related by index across those two. That means that the arrays will have the same length, right? They have to for that to work. That's also 1, 2, 3. That's also not the case. Well, actually, it is. Well, it happens to be the case. It doesn't have to be the case here in this example, but if I'm using parallel arrays, it absolutely will be true that they are the same length. It's a great question. I think that the other thing to say about it is that while I did speak on the topic, while you could see mention of parallel arrays on the exam, I think it's in some of the practice questions even. Since I haven't asked you to do it on an assignment yet, I think it's unlikely you'll see a whole lot of code related to it, probably more conceptual stuff. Yeah. Any other questions before I move on to another example, or any suggestions for another example? If anybody has a suggestion for one. Yeah.
I don't have a specific suggested example, but I would just like to ask on the hierarchy of the operators, like plus, minus.
Okay. So, I mean, the general answer The question to repeat so everybody can hear is I think you're asking about order of operations, right? The general answer to that is especially for arithmetic, it's the same as you learned in math class. So PEMDAS or however you learned it, right? That applies here. Multiplication happens before addition. And if I have two multiplications, it's going to go left to right, just like it would in math class. That is all still true. Same order of operations that you would see in math class. However, what makes things a little bit trickier is that, unlike math class, we've introduced more than just multiplication and division here. We also have things like greater than and less than and equals to and the and operator, right, that we've seen. And so do we do those before addition and subtraction? Do we do those before multiplication? That's, I think, a very valid question and something to be aware of. And I would suggest that, if that's something that you are concerned about, take a look at operator precedence, which is just a fancy name for order of operations. I should probably say Java to be more specific. And here is a list of the operator order of operations. The way to interpret this is, I believe, from top to bottom, meaning that this stuff's going to happen first, and this stuff will happen last. There's some stuff on here that we have not talked about, so we have not seen anything that looks like this in this class, right? You can safely ignore, any symbols that we haven't discussed. Let me talk to you in general, though. You can see that here is parentheses at the top of the list, so there's P, right, in the PEMDAS. Exponents, there actually is no exponent operator in Java. You have to use math.pow or something like that instead. So you're not going to see that appear on this list, but you do see addition and wait a second. Oh, this is the actual addition and subtraction. I'm sorry. Don't be confused by, see how it says, this is a confusing chart. Let me see if I can find a better one. Sorry about that. Okay, this one is a bit better, although it doesn't include parentheses, but maybe minus that missing value. Parentheses would be up here at the top. Here's multiplication, division, and modulus, which is related to division, right? Modulus is related to division. That's why it's on the same order. Then there's addition and subtraction. We haven't covered these, so don't worry about them. We have covered these, greater than, less than, equal to, right? So that happens after addition and subtraction. Ands and ors, right? There's and, there's or. That happens after addition and subtraction, right? After addition and subtraction. So for the exam, what does that mean in the general case? If you have arithmetic, addition, multiplication, division, whatever, do that first. In whatever order it needs to happen. Follow PEMDAS. Follow the usual order of operations rules. Do all your math first. If you have comparisons, greater than, less than, equal to, that happens after the arithmetic. Those are going to happen after the arithmetic. And then if you have ands and ors, which are called logical operators, those are going to happen after any comparisons that you have. So it goes math, comparison operators, which are greater than, less than, equal to, and then logical operators, which are and, or, and not. That's, I think, a good general order that you can use if this operator chart's got too much information for you to properly decipher. Great question. Any other questions or requests before I pick a random problem out of a hat? Okay, yeah, what's up?
Can we just look at a problem with Booleans?
With Booleans? I mean, I think many of these are going to include Boolean values, but yeah, sure, we can find something. Let's see. These are all great problems, but I'm trying to find one that focuses specifically on some Boolean values as requested. I like this problem. Well, yeah. Sure. let's do this one. I think this will be good. So the task is to generate random integers between the value of 1 and 100. Random integer values, notice? Random integer values, okay. We then need to count how many times the random numbers that are generated have fallen above some user-supplied threshold. So we're going to ask the user to enter in a positive integer first. That's the quantity. How many random numbers do we wish to generate? Then we're going to ask the user to enter a threshold between 1 and 100. So I'm going to say, give me 10 values, right? And my threshold is 75. So I'll generate 10 values. If it's greater than 75, I'll remember that. And then at the end, I'll say, you know, I would expect roughly 2 or maybe 3 values of the randomly generated ones to have been greater than the threshold. In that particular case, it's random though. So we actually have to generate the values and count them and see. So let's work through this process. There's a lot of parts here. Well, I mean, just 2 parts really. One is we need to generate some random values. And we know how many we need to generate because that's been given to us. I think actually before I start writing code, I do want to answer another common question. If I ask you to use, if I ask you to get input from the user like this, I will almost always give you the scanner code. In fact, I would even take the almost out of that statement. I will give you the scanner code. That is not something that you need to memorize or put on your sheet. If I ask for user input on a problem, I will give you the scanner code. I will give that to you. I would also like to take a moment and phrase that in the opposite, because I see this happen a lot. If I give you a problem and I ask you to write code for it, and there is not scanner code in there, don't put it in. Do not put it in. I will give it to you if you need it. A lot of times students will assume that they just need to use scanner for everything. That is not a safe assumption to make. Scanner will not be needed on every problem. If it is needed, I'll give it to you. If it's not there, don't put it there. That is a recipe for disaster. That's a good way to lose a big chunk of points on a problem. So here I've given you the scanner code. This is very similar to what you would expect to see if I asked you a similar problem on the exam. First thing we need to do is generate this number of random numbers. So I need a loop to do that. I think a for loop works really well here because I know exactly how many times I want this loop to run. I want it to run this many times, right? Yeah, question.
It's slightly disconnected, but jumping back when you were talking about importing like scanner and such, when we're writing code on the exam or pseudocode or whatever we have to write, will we be graded on handwritten syntax or no?
Oh, great question. The question was, are you going to be graded on handwritten syntax? So the way to think about that, I definitely want you to try and write the code correctly, right? That's the goal. However, I understand that humans make mistakes, and I even make mistakes. You've seen me make mistakes up here, right? That's part of human nature. So the rule that I use on the exam, if I forget a semicolon, right, Eclipse is going to tell me, hey, you forgot a semicolon. Put a semicolon in there. I'm not going to mark off for that. I believe you're a smart enough person to read what Eclipse says to you and put the semicolon in. Like, I understand that sometimes we forget to put the semicolon in. Same thing for like a missing parentheses, right? If I accidentally a parentheses, okay, you know, things happen. If the parentheses changes the effect of the math, then I might care, right? But if it's just, you know, I forgot to put one in, I'm probably going to let that go. Things that do matter a lot, like especially for this for loop I'm about to write, you know, where the brackets go. Oh yeah, I'm definitely going to be paying attention to that because that has a big effect on how your code runs. So, you know, make sure that the brackets are in the right place. If I don't understand what's in, you know, let's say you accidentally forget a bracket, that actually becomes a problem because now I don't know what's in the loop versus what's not in the loop. So that kind of stuff you do need to be careful about. But little ticky-tack stuff, not going to take points off for. Yeah, good question. Thanks for asking. Yeah, what's up?
This one's in close. What does that do?
Yeah, this is a part of Scanner that I probably actually should have included on the assignments, and It's on my to-do list to go back and fix, but I didn't want to do that while you were working on them, which is why you have not seen that in your assignments yet. But yeah, it's a thing that I forgot to include in the past that is also not for you to worry about. You can just treat it as magic words necessary for the scanner to run. Yep. All right, back to the task at hand. We wish to create a loop that's going to run quantity times. I'm giving you what I believe to be the simplest and most straightforward way to do this, right? Although there are literally an infinite number of ways that we could write a loop that does the same number of loops. Correct? I mean, I can count by 2s if I want to. I could count, by whatever. I think it's kind of silly to do that, but you could do it. You could use a while loop here if you wanted to. Again, I think a while loop is a bit clunkier, a bit more cumbersome, perhaps, but nothing wrong with it. You would get full credit as long as it loops the proper number of times. Yes?
Either now or after this, can you go over when we should use for versus while loops?
I mean, I've kind of been trying to do that to some degree. I chose a for loop here because I knew exactly how many times it was going to run. While loops are good when I don't know that. So the best example for that is on assignment 2. When you ask a user to type in a number of sticks, right? They don't have to type in 1 or 2. They can type in whatever number they want. I don't know how many times they're going to try and take 7 sticks. They could sit there and try and take 7 sticks all day long if they wanted to, right? So that loop needs to be prepared to run once or 100 times or 1,000,000 times, or I don't know. So while loops are great when I need to repeat something, but I have no idea how many repetitions I need. For loops are great for when I know how many repetitions I need. But there are a lot of times when both will get the job done. And on the exam, I'm going to take either, as long as it gets the job done. Yep, great questions. All right, I've got a loop now that's going to run, this many times. We now need to generate random values. So this is something I've spoken about in class. You've had to do it on assignments, but it's a great thing to review. I actually get lots of questions about how to generate values between a certain range. There's a little formula. There's a formula you can use. Talked about it, I believe, in one of the videos. It's based on the lower bound, the upper bound, and the total range. So the range of values that I want to generate here, there's actually going to be 101 possible outcomes, right? Or is it just 100? I'm going to be off by, I think it's just 100 actually. Yeah. 1. I don't know why I'm counting on my fingers. Okay, never mind. Yeah. So, you could even, some people like to make variables for this, right? You don't have to. I'll show you how to do it without, this necessarily. But the range is the biggest number minus the smallest number, right? Just like it is in math class. That's the range, right? Now that we have that information, we can use our friend math.random. What kind of values does math.random give us? Between 0 and 1, but remember, it does not include 1. Up to 0.9999999, but never 1. Never, ever, ever 1. Okay, so I wish to multiply that by the range. Think about the effect that has. One way of doing this is to consider both extremes of math.random. If math.random gives me 0, 0 times the range is 0, right? Well, that's not quite what I want. So we also have to add the lower bound, which in this case is 1. We have to add the lower boundary. So if this is 0, 0 times whatever the range happens to be is still 0, but I'll get a 1 back out. So the lower bound of math.random gets me the lower bound of my range, right? Let's talk about the other thing. If math.random gives me 0.9999 repeating, that's going to multiply by the range, which is 99, right? Which will get me, that'll be 99 point something, right? I can't do that math in my head, actually. 0.99 times 99. 98. So I think I am off by 1, actually. Yeah, I think I am off by 1. because when I add 1 to 98, that gets me to 99, and I was hoping that I would get 100 back out. So I think the proper way to compute the range is to add 1 to that. I think it's because of the fact that I'm including 1 as a result, right? So there's actually 101 possible numbers that I could generate. 1 through 99 plus. Am I wrong about that? I don't know why I'm having such a hard time with the 1 values today. Anyhow, the final piece of this equation is to recognize the fact that we do in fact need an integer here. So if I get 90, 9 point whatever, I don't want the point whatever. I just want the integer value. And we can store that in a variable. What I want to do is just test this real quick and see what kind of random values we get to make sure that I've got the random values happening properly before we move on to the next step. So this part doesn't really matter. Whoops. I did get 100 back out. That's good. Did I get 101 anywhere? No, I got 100 a couple times. Yeah. Okay. I know it seems silly that I'm struggling with what appears to be such a simple concept, but this is actually a common problem in computing called an off by 1 error. It's a very common error. It's very common when doing this kind of arithmetic to be off by 1. So if you want to look at this in a general sense, I'm going to include some additional variables here so that we can type this out more like a formula as it would appear in math class, right? This will work for any range. Just change your high and low bounds to whatever range you wish to generate for random numbers. And this set of equations here will get the job done. So if I wish to generate values from, negative 10 to positive 10, right? Think about the effect that would have. The range would be positive 10 minus negative 10 plus 1, so that's 21. 21 would get multiplied by whatever random number is generated. Oh, actually, there's one mistake here. Sorry. There we go. The value that gets added is the lower bound. Right? So if I'm generating values from negative 10 to positive 10, I get 0 multiplied by the range, which is still 0, plus negative 10. Boom. Right? That's my low range. If I get 0.999 out of here, 0.99999 times a range of 21 is going to get me 20 point something, right? Plus the negative 10 is going to get me 10 point something. And when I cast that to an integer, the point something gets chopped off and I'm left with 10. So doing random numbers in this way allows me to generate them in any range I can possibly conceive of, even including negative values. Yeah, what's up?
Where are you using the threshold integer?
I'm not yet. I'm just focused on the random numbers right now. Haven't even gotten to that part yet. Yeah, what's up? What is this? Can somebody tell me what that is? That's a cast. What type does math.random give me? Doubles, right? I don't want doubles. The problem specifically says random integers. Random integers. That also means that 2.5 is not an acceptable random value, right? 2 is good. 3 is good. I don't want to see 2.5. So in order to ensure that, I have to use a cast. This is a double. This takes that double and turns it into an int. I'm sorry? So this is the type of this variable. I'm actually not sure what would happen if I removed the cast here, if it would still generate the proper random values or not. I honestly don't know. It might be redundant. Well, actually, I can tell you that it's not. It says type mismatch. It's saying you can't take a double and stick it in an integer variable. It's not allowed. So there you go. It is required. Necessary. Definitely not. I am, what's this called? I'm going to make a new variable. It starts with a D. I'm declaring the variable. Anytime I declare a variable for the first time, I have to tell it what type it is. That's a requirement. Yep. I mean, if this is bothering you, I suppose you could get around it to some degree by just, you know, maybe like this. Just leave the variable out of the equation altogether. However, we're not done with this problem yet, and I think we're actually going to want that variable in order to help us complete the following part. Because we also asked them to type in a threshold, so we need to know if the value that was randomly generated is, what are we counting? We're counting for values that appear above. It says strictly above, right? Strictly above. It does not say above or equal to. It says strictly above. So I would ask the question, if the random value that has been generated is strictly above the threshold value that has been given, what do I want to do? I want to remember that. I want to count that somehow. Well, we need a variable. I need a place to store that information. So one way we could do that is here, but you have to be careful. I think this is a bad place to do this. Why? Why is this a bad place to make this variable? Yes?
It'll keep putting it at 0 every time
This is in the loop. It's going to run through this statement. It's going to run through these statements top to bottom every time I go through this loop, right? So even if I come down here and I say count plus plus, the next time I go through this loop, it's just going to reset it back to 0. That's not what I want, right? I want it to remember that value. So that tells me that I need to take this statement and not do it here, but outside of the loop. Has to happen before the loop starts. All right, set it to be 0 here. If I find a random value bigger than the threshold, I'm going to count it. And then I think the last thing it said to do is print out that value at the end. I believe this to be a solution to this problem. There's probably a bunch of other ways you could do it. In fact, most people, I think, would probably try to condense this down into one line. That's typically what I'd see. You can skip this whole thing by just, you know, putting in this. This is probably more like what I would expect to see on an actual exam, but if it helps you to, you know, make the extra variables and compute out the formula step by step, I highly encourage you to do that. That is always, always, always okay. We can, of course, run it too, just to verify that it makes sense. I mean, if I say to generate, you know, 1,000 random values and tell me how many appear greater than 75, I would expect roughly 250 of them to be bigger than 75, right? Roughly 25% of the 1,000 variables. And okay, I mean, not exact, but in the right ballpark. If I run it again, I would expect, you know, and use the same values, I would expect a different number. I mean, I suppose it could randomly hit the exact number that we got last time, but I would expect, oh, whoops, well, I typed in 25. That's my fault. But still, got roughly the right number, right? It's not going to be on the nose necessarily. 256 that time. All right. This is an indication to me that it seems to be working properly. Any questions on this one or anything else we've discussed before I hop in and take a peek at something else? Okay. Any suggestions on where to go next? Any problems you want me to look at or topics you wish for me to cover? I was, you know, if nobody suggests anything, I was going to maybe look for one that uses a two-dimensional array to go through. but open to, I saw at least one thumbs up. All right, let's do one with a two-dimensional array. I'm talking about arrays, I mean, you know, I've taught this class enough times to know that arrays are typically what students are concerned about for this exam. I'm assuming that to be the case here, but please, of course, if you have questions about other stuff, I'm happy to go over any of the concepts. There's one problem in particular that I know uses a two-dimensional array, if I can find it. Oh, I'm looking at the code reading problems. That's why I can't find it. It's a code writing problem. That's a two-dimensional array, but yeah, I like this one. Let's do this one. So for this problem, you are given a two-dimensional array, and you are being asked to compute the sums of the columns. The sums of the columns. So 1 plus 4 gives me 5. 2 plus 5 gives me 7. 3 plus 6 gives me 9, right? So this is supplied to you, and you need to create this. This is a one-dimensional array that contains the sums of the columns. Now, one thing to pay attention here is this note, right? I have given you an actual array here to use for practice, and I'm going to use it as well. But on the exam, what you're going to see if you get a problem like this is going to look something like this with just, come on, stop that. Oh my gosh, why? Eclipse, please. There we go. You're it's trying really hard to help me out here. On the exam, you're not going to see actual values here. You're going to see ... meaning anything, right? Any numbers. Your code should work for any two-dimensional array, not just this one. I want to make that extra super clear. We cannot write code and test code without using exact values. That's why I've provided them for you. Another way of thinking about this is that if you think you have a solution, then change these numbers and make sure it still works. Add another row and make sure it still works. Add 3 more rows and make sure it still works. Add another column and make sure it still works. That's the kind of solution I'm looking for on the exam. Something that will work for any two-dimensional array that you are given, not just this specific one. So if I'm writing code for that purpose, two-dimensional array, most people usually jump right to this nested for loop structure. I actually think that'll work for this problem, but be careful. This may not be necessary. Just because there is a two-dimensional array does not automatically mean you're going to need a nested for loop. It is possible, I would say perhaps even likely, that you need a nested for loop if you're operating with a two-dimensional array. The question to ask yourself whether that's necessary or not, ask yourself, do I need to visit each and every position in this two-dimensional array in order to accomplish this task? If the answer is yes, then get out your nested for loop. If the answer is no, I don't need to visit each and every single one of these values to accomplish this task, then that nested for loop may not actually be necessary. So be careful with that. Keep that in mind. The classic nested for loop is to use one loop for the rows and one loop for the columns. So I showed this to you in class last week. I mean, I've written these nested for loops so many times. The one with the rows typically comes first. So how do I say the number of rows? How do I get the number of rows from this array? Anybody remember?
First dimension of the array.
It is the first dimension of the array, that's right. What's the code that I use to ask for that information, though? Array name.length. That's right. This is worth talking about. If this is a one-dimensional array, the length is just how many things are in the array. But this is not a one-dimensional array. This is a two-dimensional array. This is a two-dimensional array. So if I'm talking about a two-dimensional array, dot length tells me the number of rows. The number of rows. So this loop, I am making the claim, is going to go from 0 up to the number of rows. This loop controls the rows. I'll write a similar one for the columns. I'll use J instead of I. So how do I get the number of columns back out? This ain't it. This is the number of rows. How do I get the number of columns? This is tricky. Bracket 0. This is the number of columns. And the way to think about this is go to row number 0 and tell me how long that row is. The length of a row is the number of columns. The length of a row is the number of columns. Okay? So I've got my nested for loop. If I want to, I can, show you how this works by printing out I and J, because I think it's important to understand the way that this nested for loop structure is going to be, traversing the array. We can see that our first stop, I is 0 and J is 0, then I is 0, 1, I is 0, 2. So if we think about how this translates to the array, right? This is 0, 0, this is 0, 1, this is 0, 2. It's going across the rows, left to right, just like a book, just like reading a book. So I start in the top left corner, that's 0, 0, and I go across the rows. Is that what we want here? I actually don't think it matters. Some students would look at this problem and say, we're computing the sums of the columns, so maybe we need to swap these two. I think you could. I think you could swap these two loops and go down the columns instead of across the rows. That is absolutely 100% possible, and you absolutely 100% could solve this problem that way. I also don't think it's necessary. I think you could do it either way. You could do it this way as well, right? The important thing is actually the piece that we haven't included yet, which is the array that's going to store our result. So let's talk about this guy. We need to make this array. It doesn't exist. I gave you a two-dimensional array, and we need to create and fill this one-dimensional array that stores the answers, that stores the sums. So let's create that one-dimensional array. The sums are going to be ints, right? Because all these are ints, so everything else is going to be int. It's a one-dimensional array, so not two brackets, but just one set of brackets. I can tell it's a one-dimensional array just by looking at it, right? Just by looking at it, there's no rows and columns, it's just a vector. Okay, call it something. I'll call mine result. If I knew what values went in here, then I could use curly bracket notation, but I don't. I actually have to compute that, right? That's what this code is going to do eventually. So what I need to do is make a new integer array. But in order to do this, I have to specify how big it is. How big should this array be? Close. I'm computing the sums of this array, and I got 3 values back. Why? 3 values because I have 3 columns. The size of this array should be the same as the number of columns. So we've already talked about how to get the number of columns. It's just like this. Or, if it makes you feel a little bit better, right? This is the same thing, just kind of breaking it up to make it a little easier to see, right? Let me take a moment to explain. Well, no, never mind. Let me finish the problem first, and then I'll come back and take a moment to explain what I was about to say. We're actually almost done, believe it or not. I think once I tweak this line a little bit, we'll be good to go. So, the way that we've written this loop, we've actually printed out the results. We can see that I represents the row that we're on, and J represents the column that we're on. So in order to access the values from this two-dimensional array, I can use I and J as my index, correct? So data at I, J, in fact, if I wanted to, I could just, print out that real quick. This is not what the problem asks for, but just to show you how this nested for loop structure is working, right? I can see if I plug those in, I get the numbers of this back out, left to right, top to bottom, just like reading a book, right? But I need to compute the sums. So what I wish to do is actually extract this value from the array and then add it somehow. So in my result array, I need to somehow take that value out of the data array and sum it up. Well, consider that if the value comes from column 0 here, that's going to affect the sum in position 0 of my one-dimensional array. If it comes from column number 2, that's going to affect the sum in position 2. So really, this is what I need. Or, so take whatever value is in that position and add this new one to it, or we could actually simplify this if you would prefer and just do a plus equals. There is a very big assumption that we're making here. It happens to be correct. What's the assumption that I'm making for this to work? Anybody know? What's in the array after I create it? All zeros, all zeros. So when I add take the first one out of the array and add it, I'm adding it to a default value 0 that happens to be in that array. That's an assumption that I'm making. It would not necessarily be a bad idea to, ensure that the result array is all zeros at first, but on the exam that this question was given, I didn't bother with any, I let that assumption stand. This will get the job done. I can prove it to you by, coming down here, and since we've been on the topic, I'll use a for each loop to print out the contents of this array and show that it does in fact have the proper results in it. This was not requested, so the, oh, I misspelled that word, didn't I? The solution to the problem is this. If you had put this down on the exam when this question was given, you would have gotten full credit. But so we can actually test it and see what's, verify that it's working, I add this little extra for each loop down here to just print out the values in my results array. Let's make sure that we get the proper values. 5, 7, and 9, just as we expected. And then I want to double back and make one thing extra super duper clear, which is that, let's say I came in here and, just said, all right, there's 2 columns and there's 2 rows and there's 3 columns here, right? And I could do the same thing here. I could just say, all right, there's 3 columns. So I could just, leave that out of the equation, leave the data.length stuff out of it entirely and just put the numbers in there, right? And actually, even if I run it, it'll still give me the correct values, right? 5, 7, and 9. However, if I come up here and add another row to this array, that should change the results. That should change the sums. There are now, 3 values in each column, not just 2. That should change my results. But because I did not use the size of the array here, I just used numbers directly, right? What I get back out is not correct. it's not correct. Specifically in this example, what's the problem? I said that there's only 2 rows. So it's going to do the first row, it's going to do the second row, and then it's going to think it's done, even though there's a 3rd row over here. It gets even worse if you try to extend out the columns, right? Or, I mean, I think the worst situation would be, what if you take a column out or take a row out? Now there's only 2 columns, but my code says there's 3. I just assumed that there would be 3. That's not a safe assumption to make. And now when I run this code, I get an error. It says, you know, index out of bounds exception, right? There aren't that many columns. So when I say your code should work on any given array, I mean that. And the way that we do that is by making sure that we do things in a more general way by referencing, by asking the array, how many columns do you have? How many rows do you have when it's appropriate to do so? Just by changing this to you know, incorporate those things back into our code, we now get code that doesn't error and works functionally on all of them. 1 plus 4 plus 4 is 9. 2 plus 5 plus 5 is 12. This code will work for whatever array I give it, no matter how many rows it has, no matter how many columns it has. This is a correct answer. If you just hard code in a number here, you're saying, I expect all arrays to have 3 columns. All arrays that I ever get from now until the end of time, 3 columns. No more, no less. And that's just simply not true. That's not a safe assumption to make. So just keep that in mind as you work on this problem. Any questions? Yes?
On line 37, when you have the plus equals to in your data for I and J, I'm just wondering, like, you're not really understanding how that sums the 2 values.
Okay. Let's walk through the debugger. I think that's a great question. Question was just about line 37, how this is actually computing the sums. Let's walk through the debugger and see exactly how that works. I set my breakpoint on the exciting part. I generally don't set my breakpoint on a variable declaration. I don't consider those to be terribly exciting, right? They usually are pretty straightforward. The loops and stuff are where things get crazy and kind of complicated. So that's where I'm going to set my breakpoint, is right on these loops. First off, let's examine what's in our result array. I can see it just has 2 zeros, so it's just got zeros in it to start. So I'm going to start stepping through. I see that my value of I is 0. My value of j is 0. And this line, if we examine what it's saying, specifically says, go to the position in this array at I, you know, whatever values at position I and j, that's the 1, and add it to the result array at position j, which is 0 in this particular case, right? Since j represents which column I'm at. So it's going to extract the 1 from here and add it to whatever is in index 0, bucket 0 from my result array. So there I see the 1. J is now going to go up 1. I'm now going to be looking at this 2, right? I'll be looking at this 2. That 2 is in column number 1. I know that because J is 1. J represents my column. So I'm going to extract out the value from my 2-dimensional array at position 0, 1. That's the 2. And I'm going to add it to my result array at position 1. So once I do that step, I see, all right, that's a 2. I finished the first row, but I still have 2 more rows to go. So if we keep going, we'll see that I is now bumped up to 1, and j is 0. So I'm looking at this value, the first value on the second row. The code says to take that value and add it to my result array at whatever column j says that I'm at. So it's going to take the 4 and add it to the 1 that is already there from the last time, and that's going to get me the 5. I is going to go up 1, so now I'm looking at position 1, 1. I'm going to take that and add it to position 1 in my array. That gets me position 7, or it gets me to value 7. And then we're going to repeat this process for the last row. You can see I'm in row 2 now. So I'm going to take that first 4 and add it to the 5 to get 9. I'm going to take that next 5 and add it to the 7. That gets me my 12. And we're actually done at this point. This code just prints out the contents of the array. If if this line of code is confusing to you and you would rather write it like this, that's fine with me. I don't have a problem with that. They are equivalent. This is equivalent to what I had up here before. But it takes longer for me to type, so I usually like to do it the other way. But I don't, you know, whatever works for you. I hope that answered your question. I got about 10 minutes left, which means I can maybe answer a few more questions or go through one more quick coding problem. Does anybody have anything for me? If not, I'm just going to pick one more quick one. I think I actually might even have one in mind. Okay, yeah. I was reminded of this by question that somebody asked me earlier. Wants the user to enter in width and height and compute the area of rectangles until we get a rectangle that results in an area of 0. So we have to use the scanner a lot here. And so I'll, I need a prompt that says enter, what does it say? Width. Okay. And I'll need another prompt for the height. And then after each of these, I'm probably going to want to create variables. Now, you can see from the examples that it's allowing doubles in this case, right? Doubles are okay. So double width is equal to in.nextDouble, and double height is equal to in.nextDouble. Computing the area should be pretty straightforward. Just simple multiplication. And so this will work for one rectangle. It says enter a width, I'll just do the example, 10.5 and 2. It tells me that the area is 21. Okay, that's fine. But we wish to do this over and over and over again until the user gives us a rectangle with an area of 0, and then we wish to stop. So there's repetition involved here, but I don't know how much repetition is involved here. The user could give me a rectangle with an area of 0 right out of the gate, right off the bat. Or they might wish to compute the area of 1,000 rectangles before they give me one with an area of 0. Or any number in between, right? I don't know what that person's going to type in. So this is a great classic example of using a while loop. Here. While the area is not equal to 0. Okay. Area doesn't exist yet. I didn't actually create a variable for that, but I can. Unfortunately, it's still not going to work because of the fact that this variable is inside. So I'm trying to use this variable here before I've created it. Do you see the problem? I'm asking, is the area not equal to 0? Well, I don't even create the area until down here. So actually, this is a similar issue to what we saw last time. Let's make this outside of the loop. And, I can just set it to be anything at first. I really don't care what it is here. I don't care at all what this value is here. Well, as long as it's not 0, right? 0 would be a bad choice, but anything else is okay. And then down here, I'll actually, compute that value, print it out. I believe this to be a solution to this problem, but let's test it. So I can enter in 10.5 and 2, and okay, there's my 21, and I can put in another one with the 5, height of 5. There's 25. All right, 6 and 7.3. All right, cool. It's working, right? As soon as I type in either a height or a width of 0 would do the trick, right? anything that's going to give me an area of 0. So if this is 7.5, but the height is 0, that should give me an area of 0, and the program is stopped now. It stopped asking me to type values in. It's over. Right? The area became 0. The while loop said, oh, the area, this is false. I have to quit. This is very similar to what we asked you to do on assignment 2, when the user had to type in the number of sticks, right? Keep asking them the question until you match some condition, and then stop asking them the question. Same idea. While loop's a great one for that. I think this is a good solution to this particular problem. Any questions about this one? Notice one other thing I want to mention, right? I'll leave you with this final note. I didn't use any arrays here. Sometimes students get so focused on, arrays are on this exam. I got to learn arrays. I know they're going to be on there. Not every question is going to use an array. We also talked about loops. We also talked about if statements. We also talked about variables. We also talked about all kinds of other stuff. Don't force an array into a situation where it's not necessary. A lot of times it ends up overcomplicating the problem and making it a lot harder than it needs to be. Yeah, I guess we're out of time. If you have any more questions, I'd be happy to stick around and chat afterwards. Otherwise, I'll see you in class or at the exam.